welcome to Caesar's Snack Sandwich. Today I'm going to be taking a quick look at AXELAR. Okay, AXELAR and this Squid Router, which kind of is built on top of AXELAR. It's pretty interesting. It's a new solution for bridging tokens from one blockchain to another. And this Squid Router here is a kind of front end plus some contracts to kind of help you to utilize this AXELAR blockchain for bridging. Okay, it's a bit hard. Like if you go to the docs, which is here, they're pretty technical in the sense that, you know, like if you look there, they're constantly throwing smart contract code at you. So it's a bit hard to get through, but I did read through all these docs. For the most part, I didn't read too much on how to configure a node and how to, you know, play in the sandbox and stuff like that. But I read through most of the docs here, and then I also went through their blog, because their blog's kind of written more in simplified English, kind of explains things, and I read this article here on Medium. So this is kind of what I'm using to make my flowchart and explain it. So as always, you know, I would suggest you to dig a little deeper, you know, find out some more. I went to the Discord, and actually the Discord doesn't have any. I couldn't figure out how to get myself any any messaging abilities, so I couldn't actually ask any questions. But there is a question that I don't know how exactly something works. But I'll get to that when I go through the flowchart and when I come across that, and I'll kind of show you what I have there. Okay, so let's swing over to the flowchart, and I'll explain to you how AXELAR is solving the bridging problem in a different way than what traditional bridges have been doing. Okay. If you would like to support the channel, I would suggest you to check out the secretsandwich.xyz. It's the Secret Sandwich NFT project. You can come here, you can mint an NFT, or you can come and check out your NFTs. Okay, so let's get back to it. Okay, so here we are on the flowchart. We have dollar bill. He has some USDC. He wants to send it across to another blockchain, right? So before I can kind of get into how AXELAR is different, let's talk a little bit about blockchains in general. So blockchains are interoperable, so they cannot work together. They cannot talk to each other. You can't have a smart contract on Ethereum that functions with a smart contract on Phantom in this case. Okay, so they're siloed. There needs to be something in the middle, and that's basically what the bridging solution is the thing that the tech that they put in the middle between the two blockchains that monitors both sides. Okay. So let's say Dollar Bill wants to send himself some USDC, or he wants to send some USDC to his brother on a different blockchain, or he even wants to, you know, interact, you know, send that USDC to some smart contract on another blockchain. Okay. So there are two main kinds of bridges, and there are the ones that transfer tokens and the ones that mint tokens. So they both have their pros and cons, and before I used to really push the idea of like minting and burning, and if you look at my videos and stuff like that, you'll see I talk a lot about minting and burning functionality of bridges. But the problem with this is sometimes there is infinite minting and stuff like that, and some exploits that happen on huge scale because of this minting and burning stuff. So there are, like I said, two kinds of bridges. There are transfer bridges and minting and burning bridges. So I'll quickly go through it. So let's say he has some USDC. It's USDC on Ethereum. He would deposit it into this chain. Something in the middle would see that, and then it would call some function on this other blockchain and either transfer out some USDC to him, or mint him some new kind of USDC and send that to him. Okay, so that's generally how these bridges work. Key thing is that the thing in the middle that's watching this contract for these inputs and then calling this contract for the outputs. And again, you have to pay gas on that. This middle entity would need to pay gas to transfer these tokens out of this contract or to mint from there. So here we have AXELAR. AXELAR is the key thing in the middle today that I'm going to be talking about. But they perform quite different than other things. What makes AXELAR different is it's a proof-of-stake Cosmos blockchain. So that means it has a whole bunch of validators. Okay, so these validators are monitoring the source chain contracts, right? So they're monitoring both sides, right? But like because it might go the other way. But let's say in this case, it's only going one way. So they're monitoring this for deposits or for a call on this that says, basically I want to deposit this and I want it to come out here, right? So they're monitoring this, they watch it, and then they reach consensus on this call that has happened, and then they call the function on the other side and pass it out. So like I said, it's a proof of stake blockchain, which is the first I've seen to do this. Now, most of them is just done on a back end with some servers. The servers are monitoring this, and then they call this function, right? And there is some centralization issues with these bridges. But with here, it's a distributed network of Cosmos nodes. So these guys don't know each other. They can't collude. They can't talk to each other so much, right? It is a blockchain, so it's a proof of stake blockchain. So it depends on the decentralization of that blockchain itself. And I can't speak on how decentralized this AXELAR blockchain is. That's something for you to do. So what they have to do in order to write blocks to the AXELAR blockchain is they will need to, of course, stake. So they will have to get some AXL tokens. They will need to stake it. And then every time they're writing blocks, they're rewarded with AXL tokens that are inflationary, okay? So just like all proof of stake blockchains, so they monitor this, they build a block, they send it, they get consensus, and then when that's achieved, then this side one would be called by them. So they're kind of like a server, but they're not run by a single entity or some company or individuals. They're a decentralized blockchain, okay? That's what makes them special. Now there's some things in here that we need to talk about, and that is the gas, okay? In this case, there is, of course, boosted bill is going to, or sorry, dollar bill is going to have to pay gas to call this function on this thing. So that's going to send his USDC into this contract here, as well as tell it the perimeters of what he wants done over here, right? So he's going to have to pay Ethereum on there, right? But what AXELAR is able to do is they're able to basically quote the estimated amount of gas that's going to be required to pay the gas at these other sides. So dollar bill will only have to pay ETH in gas. He's not going to be asked on this wallet to sign a transaction, and he's definitely not going to have to pay any of the AXL. But this is a blockchain as well, so it needs to be paid gas. So what it says inside the documentation that I was reading was that his ETH will be used to pay this ETH transaction, but he will also be quoted an amount of ETH that will need to be used to buy the AXL token to pay for the block space on the AXL, as well as an optional pay for this destination. Because there's another option is that this contract on the destination chain might subsidize these transactions and have, like, let's say Phantom in this case, sitting in here to pay the gas. So that could be the possibility, especially if it's something, individual that he wants to use, he might subsidize this and run it that way. But in most cases, I would think, it would just be free. It would just be, they would just depend on, this side, like the dollar bill over here to pay the gas of the entire string of transactions. So just to reiterate, so he pays gas on Ethereum to call the function. And then the AXELAR blockchain and front ends and back ends and stuff, they quote a estimated amount of gas that's going to be required to pay for the AXELAR block space, as well as pay for the gas on Phantom to mint out these tokens or to transfer these tokens to these locations. Now this is all going to be paid in ETH, so he's going to pay in ETH. And so he doesn't need to worry about holding AXL token or even Phantom token until he's over here and he needs to do stuff over there, right? Now, another thing that makes this blockchain special, there are some key features to it that make it kind of set it across from other proof-of-stake blockchains and stuff like that. And the first one is they have this diverse node operating systems. So it doesn't really explain very, very deeply, but basically these blockchains are quite diverse. Or sorry, these node operators can be quite diverse. You can run it on an Apple OS or an Ubuntu, whatever. So they can have all kinds of different node setups in the sense that, so it will allow for more decentralization, more diverse node operators. It won't be something that's very specific, and the skill set is very particular and difficult to master. So then, you know, it's harder, it's less hard to be a node operator for this AXELAR blockchain, so they say, right? The other thing they talk about is quadratic voting power, and that basically, as these node operators start to build up their stake, they get more voting power, but it takes more to gain. So like, let's say one guy has 100 and another guy has 200. He is not going to have twice the voting power as the first guy. He might have 1.5 the voting power as the second guy. And the guy who has 300, he might only have 1.75 or something like this than the first guy. So it gets more and more expensive to build up voting power as a node operator, but it's still, you know, it still rewards you for having more voting power to be able to write those blocks, right? They talk about this thing called this amplified Cosmos borrowing. So because it's a Cosmos blockchain, there's this ability for them to borrow the staking power of other Cosmos blockchains and use that to secure this network. Now that's just something that's very high overview of what they talk about. I don't really understand it, and I haven't dug really deep into that. Okay. Another thing they talk about is the rate limits of these blockchains. So these smart contracts can have more rate limits. And now what that means and how that is helpful and important is a lot of bridges have started to do this now, and it's quite important, and that is they will only release so many tokens per day in order to ensure that, like, you know, $10 million doesn't just suddenly come out of these blockchains. So it kind of slows it down. And I talked about this a little bit when I talked about the Frax Ferry as well, and how they control the amount of tokens that can come out of there, so that if something does bad happen, they can mitigate or slow down that damage, right? And then they talk about these mandatory key rotations, where these node operators are going to have to rotate their keys, so that, like, if a hacker is trying to find their keys are changing all the time. So that's kind of a good thing as well. Now there is one more thing that I forgot to write down here, and that is this is a blockchain, and it's a smart contract blockchain. So it's possible that this AXELAR can add a smart contract into the middle if some sort of innovative idea comes along. So a smart contract can be immutable. So there could be some feature inside this AXELAR phase of the bridging that is immutable and clear and predictable, right? And that can be quite good, because like I said, most of them are run by servers and they're black boxed. So you have really no idea what's going on inside that black box. But if it's a smart contract, then it's quite predictable and easy to understand and transparent what's going to happen inside that AXELAR blockchain if they have smart contracts in there. Okay, moving on. So I'm going to talk a little bit about the Squid Router, which is a router that's built on top of this AXELAR blockchain. So basically, it's if you think of it like it's these gateway contracts here. So they've deployed their own gateway contract that uses the AXELAR as the bridge between their contracts, their gateway contracts on all the chains. And the service they provide is they allow for all kinds of like swapping and stuff like this, and smart contract calls. So, you know, like if a dollar bill here, let's say he has his USDC is in Aave or something, then perhaps he could use this Squid to withdraw from Aave and then swap USDC for, I don't know, USDT, and then send USDT across, and then when it lands here, maybe swap that USDC for, you know, Caesar token, and then deposit that Caesar token into like Caesar protocol. So all of that could be done via the Squid Router. So what I would suggest you do is check out the options on the Squid Router UI. There's not as much as what I've said, but there's definitely swaps on both sides of the chain, which is quite good. This is the first bridge I saw that has destination chain swapping. Mostly it's usually swap before you send and then send it across, right? But this one allows for swapping after as well, which is quite powerful. Okay. Now the last thing I'm going to talk about is this is a proof of stake blockchain. So if grandma has some AXL tokens and she wants to support her son's degeneracy and blockchain crypto game, she can take some of her AXL tokens and she can delegate stake them on through this. So you'd use the Cosmos wallet to do so, but you could stake. She could stake her stake her AXL tokens on one of these nodes and delegate to them and give them more voting power and more block power, and then earn some share of the block rewards that they get for writing these blocks. Okay, so that's pretty much how I understand it. As always, this is the way I understood it based on what I read, and I would suggest you to dig a little bit deeper and so forth. I did say I was going to show you this. I'm going to swing it back over in front of the camera. So this is where I was talking about the gas. That's a little bit, so you could pause it and read it if you want. But this is kind of what I was talking about. Like it has buying power for the AXL token. So when you're going to pay for the gas, you have to pay the AXL token, and then it also has the ability. It says here it's all gas pays are in the source chain, so that would be Ethereum, and that Ethereum is used to buy AXL to pay for the AXL validators, as well as the gas on the destination chain. Now, it's not very clear. I read, I digged, and I can't really find out how they're able to use that Ethereum to buy, let's say, Phantom. That's one of the questions that I still don't know the answer to, and when I finally find out, I'll know, but I won't update this video, so that's for you to check out on your own. Okay, I hope this has been useful and interesting, and I appreciate it, and thank you so much for watching, and goodbye.